You're kicking back on the couch, maybe flipping through channels or binging a show. The signal might get a little glitchy for a second, but you probably don't think twice about it, right? But what if that tiny little hiccup in your cable signal was actually a symptom of a much bigger, hidden problem? We're talking about one with consequences that reach way, way beyond your living room. Let's dive in and uncover this hidden danger.
I mean, it sounds like something straight out of a Hollywood blockbuster, doesn't it? The idea that your fuzzy TV signal could actually interfere with a passenger plane, it just seems impossible. But believe it or not, the answer is yes. It absolutely can happen. And the story of how we discovered this danger reveals a kind of invisible battle being fought in the airwaves all around us.
And the root of the problem? It's surprisingly simple. You're not looking at some kind of catastrophic failure. All it takes is a small break in the line, just like this one. A little crack from some bad weather, maybe a staple that was put in the wrong place, or even just a squirrel chewing on a cable can create an opening. And this is the weak spot. This is where signals that are supposed to be contained leak out into the open air.
So to really get a handle on the risk here, we first have to understand the problem itself. It's a fundamental issue with the coaxial cable technology that, for decades, has brought TV and internet into pretty much all of our homes. The problem has a name: signal leakage.
The technical term is signal egress. Just think of the coaxial cables carrying your TV and internet as a closed plumbing system. And when there's a break in that system's outer shield, the radio frequency signals inside, the very signals carrying your shows and your data, start to leak out. Honestly, that leaky water pipe analogy is perfect. It's an unwanted escape that can cause a ton of damage where you'd least expect it.
Now, this weakness is actually a two-way street. When the signals leak out, we call that egress, and that's what can interfere with really important communications. But that exact same hole allows outside noise to get in, and that's a problem called ingress. Ingress is what you see on your end as a customer: a pixelated picture, a frozen screen, or just frustratingly slow internet. Both of these problems, egress and ingress, stem from the exact same physical flaw: a break in the cable's shield.
And listen, this is not just some theoretical problem. This danger became terrifyingly real more than 40 years ago in an event near Harrisburg, Pennsylvania that would go on to change telecommunications rules forever.
This was the warning shot. Way back in 1971, the Federal Aviation Administration, the FAA, was already sounding the alarm. They knew that the frequencies being used by the booming cable TV industry were dangerously close to the ones they were using for air traffic control. Their fear was simple and very direct. Broken cables could radiate interference.
So the conflict heated up pretty fast. The FAA voiced its concerns in '71, but the Federal Communications Commission, the FCC, basically dismissed them. Their reasoning? They said there were no actual reports of interference yet. The classic, "it hasn't happened yet, so it's not a problem" argument. And for a few years, it actually seemed like they might be right. But then, April 1st, 1976 rolled around, and everything changed.
On that day, pilots on approach to Harrisburg, Pennsylvania, suddenly found their air traffic control channel was just filled with static in a really loud tone. The interference was so bad it actually got stronger as the planes climbed higher. The investigation that followed, by both the FAA and the FCC, found the source. The local cable TV system was just bleeding RF energy from multiple leaks. And one of the worst culprits? Get this, a simple, open cable connection in a single customer's home. That one little flaw was powerful enough to disrupt aviation.
Now, the Harrisburg incident led to some strict new rules for cable operators. But the story doesn't end there, because as technology has evolved, so have the risks. The whole nature of the threat has really shifted over time. See, back in the 70s, the big worry was the very high frequency, or VHF band. That's what aircraft used. Today, cable systems use a much wider range of frequencies, pushing way up into the ultra-high frequency, or UHF spectrum. And this is the exact same territory now used by our 4G and LTE cell networks, and, crucially, by the radios for police, firefighters, and other first responders. Take a look at this. This is a modern map of the problem. Those red pins you see, they aren't marking bad TV reception. Nope. They're showing locations where outside LTE cellular signals are getting into the cable network. Remember ingress and egress? Well, this map is proof positive that wherever outside signals can get in, the cable's own signals can get out and cause interference.
Okay, so here's the crucial point.
A cable company can be perfectly compliant with all the old FAA rules, showing 0 leaks in those old VHF aeronautical bands, but still have a huge leak up in the higher UHF bands. This invisible leak might not affect a 747, but it could absolutely disrupt a firefighter's radio during an emergency or mess with your 4G service.
So how do cable operators even deal with this constant, invisible threat? Well, it's an ongoing process that's part maintenance, part detective work, and kind of like a high-tech game of whack-a-mole. And the causes are surprisingly ordinary. It's usually not one big event. It's the slow creep of just environmental stress, corrosion from rain, squirrels deciding a cable looks tasty, a technician not quite tightening a connector all the way, or even damage from nearby construction. Any of these small, everyday things can create a potentially harmful leak.
And let me tell you, the consequences for not catching these leaks are severe. This isn't just a slap on the wrist. Back in 1999, a cable operator in Detroit got hit with a $55,000 fine from the FCC. Why? Because a signal leak from their system spilled right onto the 121.5 MHz band. Now, that specific frequency is reserved for emergency aircraft beacons, and the FCC officially labeled that interference a serious threat to public safety.
To avoid those massive fines, companies use some pretty sophisticated systems. They actually have vehicles that drive around, automatically patrolling and detecting leaks. That generates maps like the one on the left, marking the general location with a pin. Then, technicians on the ground use these handheld meters to home in on the exact source and get it fixed, fast.
So all this constant monitoring and repair, it's effective, sure, but it's really just a defensive game against a flaw that's built into the technology. But what if we could just eliminate the problem at its source? Well, the good news is we can.
And this brings us to the ultimate solution, the real game changer. This entire problem of signal egress and ingress, the risk to planes, to public safety, to our cell networks, it is a problem that is exclusive to older coaxial cable technology. With modern fiber optic cables, it's physically impossible for this kind of leakage to happen, period.
So why is that? It all comes down to some really basic physics. Coaxial cable sends radio frequency signals through a copper wire. That signal can and will escape if that metal shield around it is broken. Fiber optic cable, on the other hand, sends pulses of light through a tiny strand of glass. There is no radio frequency signal to leak out in the first place. The light just stays inside the glass. The problem is solved by design.
And this reality is so profound that even regulators are taking notice. As FCC Commissioner Michael O'Rielly has argued, it just doesn't make sense to force companies who have already invested in upgrading to this superior fiber technology to follow expensive rules that were designed for technology they don't even use anymore. Getting rid of these outdated regulations could actually encourage even more investment in our fiber infrastructure.
So as our world gets more and more connected, relying on uninterrupted data for absolutely everything, from our entertainment to our emergency services, we're left with a bigger question. This isn't just about getting faster internet anymore. It's about building a digital foundation that is inherently more reliable and more secure. The slow replacement of metal with glass that's happening under our streets and over our heads, well, it isn't just an upgrade, it's the end of a hidden danger.